Okay, what data finally convinced you that 9/11 was not just by 19 hijackers? You know, the final convincing was this molten metal that I learned about. And so here's a picture. It takes a minute to come up, but this one has been stabilized and shows the, oh, he didn't change the word. It's not steel. At least not mostly. It's mostly iron, I'm confident, as I'll explain. But you see that yellow hot molten metal in abundance pouring out of the south tower just minutes before its collapse. And as you get to see when it actually collapses, it fails at the same spot. I mean, it twists and buckles at the same spot. So this molten metal is a very significant event in the history. Oh, look at the white smoke coming off. Did you see that? That ash. That is totally consistent, again, with thermite, the yellow to white hot molten metal. And as the metal splashes against the cement, the columns there, you see the white interior. I mean, it's extremely hot, this molten metal. Here's a picture. It's mentioned in an appendix, a NIST report. I'm going to start talking about thermite. And I'm using the term thermite generally. If you add sulfur and some other goodies, yeah, that's thermate. But I'm just going to, it's the thermite class. And so I'm just going to use the term thermite for thermite class. The technical word is aluminothermics. So that's a mouthful. I'll just say thermite class reactions. But characteristic of thermite burning is this unusual flame. It's actually a reaction. It's white. You see it there in the middle? Between the 80 and the 83, right between there, that white, hot reaction region, and then again the white dust coming off. Well, that's just what you expect with thermite reactions. So the plume of smoke that comes off now is this white ash. NIST says that this is consistent with it being molten aluminum. But when I first saw that, I had worked with molten aluminum previously, and molten aluminum at all temperatures, I mean up to when the pot, which is steel, is yellow hot, you pour out the aluminum still looks silvery. And I'm getting ahead of myself a little. We'll show you those photos, but it doesn't look yellow hot aluminum when it's pouring in daylight conditions. I'll skip that one. Dr. Pitts said this probably, okay, molten aluminum from the plane. Somehow got across the floor, some distance away, flowed, and somehow got up to yellow hot. Now, aluminum melts at a temperature which would be red hot temperature. It melts about 600 centigrade. And so, but yellow hot is around 1,000, 1,100 centigrade. And so, how do you get it up hotter? And even if you do get it hotter, it still looks silvery. There's a fellow, Dr. Greening, said, well, maybe aluminum, molten aluminum, when you put that on rusty steel, you'll get a kind of a thermite reaction. We tried it. We did not get those highly exothermic reactions. Okay, so here's this cup now, steel, which we heated to orange-yellow hot, as you can, I think, see in the picture. And then as we poured the molten aluminum out, the aluminum still looks silvery. Okay, thermite, aluminum powder plus iron oxide, which gives you the aluminum oxide, which is the white plume, and molten iron. Now so here's a little more detail on that. I threw this in at the last. Thermite type reactions. You always have aluminum powder. And if it's just finely divided, you get incendiary. This means it reacts slowly, and it can cause fire, and it can melt through structural steel, but it's slow. There's no explosion heard with an incendiary because there's no explosion. It's slower than that. Now, on the other hand, if you go to ultrafine aluminum powder, there's a little chemistry here. It's very important, though. And also ultrafine the metal oxide on the other side, iron oxide typically used. I list some other oxides. Anyway, then it will explode. So thermite, again, there's this whole range of materials you can add into the thermite. I've listed in there. And then the fineness of the powder determines whether it burns slowly as an incendiary or immediately and as an explosion. You can do it both ways. Okay? Thermite is extremely versatile. And I would add that there are no tagans. Now, the word, I'll come back on tagans, but in conventional explosives like TNT, RDX, HMX, there's a tag, a chemical tag. So when the explosive goes off, the tag survives. Investigators can come and look, and they say, oh, this has got some, this tag in it. Tagant is the term they formally use. And now we can determine where this explosive was purchased, and blah, we catch the guy. But with thermite, there are no tags. very clever stuff. Okay, so we did experiments with thermite. On the right, you see this there at BYU. And this was actually my daughter, bless her heart, got me going on this. She did this for a science fair project. I want to do thermite. And I said, okay, Shelley. Yeah. And so, here we are. And I see the white ash coming off. It's really quite dramatic. Now this, she had a stopwatch, and she said, okay, we'll time how long it takes for the thermite to slice through the steel cup that we had it in. And so, we tried timing it. But you know what? We added sulfur. We just went to that reaction first. So it was really thermate, and it was through it. And you couldn't even, it was just through, and there's this white hot molten iron dripping out the bottom of the steel cup within just a fraction of a second. We couldn't time it. Okay, so you've looked at that. And now here's a question that gets raised. So the question is, was thermite used in the cleanup? See, this is a legitimate question. So I asked Robert Moore, who's one of our scholars, and he has looked at hundreds, probably thousands of photographs. And he says, I've seen no evidence for the use of thermite by rescue workers or the cleanup crew. Much of their work has been photographed and is widely available. Why would they create hotspots around other more significant hotspots? As you know, there's this molten metal. Most of you know that. I'll show some more on that. In fact, you see it here already. This yellow hot stuff before cleanup began, and Sarah Atlas saying the molten metal, she thought it was steel, and by the way, Loiseau thought it was steel too, but no, we've now analyzed it. This is molten metal, primarily iron. There's some component of steel when you slice through steel, but not much. Huh? Anyway, this molten metal flowed in the pile of ruins, still settling beneath our feet. This is one of the very first responders that got there. And you see this molten stuff kind of settling in the pile. They used a lot of thermite, looks to me like. Anyway, why would they use thermite in a cleanup? This would be pretty crazy. It's extremely dangerous stuff, and so on. Now, they did use oxyacetylene torches. This is part of our answer. Thermal lances also could have been used, and probably where we're trying to pin that down in an oxygen. So you see the tube that guy's got? He's got oxygen flowing up the tube, and you're actually burning a metal, iron generally. And that will allow you to cut through structural steel too. This, however, will not be confused with thermite. The residue is not like thermite. Of course, this would not be any confusion to us. Okay, let's go on. Here's one of these big chunks of previously molten metal. Huge quantities of the stuff. And here's another one you probably haven't seen. I wish we had more photos with detail, but you see this flowing material. It's kind of brassy looking in this view. Found at ground zero. Enormous quantities of this.
This is how it's been since day one. Oh, it's unbelievable. And this is 6 weeks later, almost 6 weeks later. And as we get closer to the center of this, it gets hotter and hotter. It's probably 1,500 degrees. We've had some small windows into what we thought was a core at some point, and it looked like an oven. It was just roaring inside. And it's just a bright reddish orange color. See that stuff he's pulling out? What was that, Chief? We're gonna hold off on the water. See the stuff he's pulling out?
Yeah.
It's red hot. If we hit it too much steam, you won't be able to see what he's doing.
Great.